Good morning, students. So today we are starting a new topic about merge sort and quick sort using recursion. This is the last topic in this function, and this is the last portion of function. So without delay, start with merge and quick sort. These are two sorting techniques which are used in this programming for arranging the elements. The merge sort or the quick sort depends basically on an idea of divide and conquer rule. Here, first the elements are divided into two halves, then they are conquered. This idea is based on the idea that is prepared by the British. They first divide the classes and then rule over them. Same case implies 0. So suppose I am taking some numbers 10, 6, 8, 5, 7, 3, 4. How many numbers are there? In total there are 7 numbers. So the numbers can be divided into 4, 3 or 3, 4. But if we take 4 and 3 or divide the numbers into 4 and 3, then the time complexity of the whole program decreases. Okay, because first it will check for the higher elements, then it will break down the whole structure, so it will become more easy. And this is the utility of this dividing the 4-3 rule. Okay, so if there are 7 elements, divide it into 4 and 3 halves. So first I am dividing the first set as 10, 6, 8, 5 into one group and 7, 3, 4 into another group. So when I am dividing this thing, there is suppose 10, 6, 8, 5, 7, 3, 4, the actual one is an array A. We are dividing this array into two halves, becomes A1 and A2 respectively. Now A1 consists of 4 elements. Again A1 is divided into two halves, 10, 6 and 8, 5. Right? Now 10, 6 is even divided into 10 and 6. And 8, 5 is divided into 8 and 5. Now we are comparing 10, 6. As 6 is smaller than 10, then they are swapped. So the new array becomes, for the left side of the array, it becomes 6, 10. And for the new array on the right hand side becomes 5, 8 after sorting. Swapping, because who is smaller will come in the left and who is larger will come in the right side. Right? Now we are comparing the elements. The first element of the first array is compared with the first element of the second array. Yes, the element is smaller than the first one, so 5 is swapped here, right? And 6 is placed in this position. First swapping is done. Now come to this portion. As the element is now here, so 6, or the first element of the first array, is already compared to the first element of the first array is compared to the first element of the second array. So 6 is placed here. Now this 6 is compared with the second element of the first array. 6 is compared with 10. Yes, 6 is smaller than 10, so 6 is placed here, 10 is placed here. Done. So 5 and 6 are already sorted. Now here 10 and 8 are present. First element, again we have to check that the first element of the first array compared with the first element of the second array, second element of the first array compared with the second element of the first element of the second array. No changes there. So we are coming to this portion. 10 and 8 are the two numbers beside them, residing each other. So 8 is smaller than 10. Again the numbers are swapped, 8 and 10. So the new array becomes 5, 6, 8, 10. So here I am starting or dividing the whole number, breaking the numbers or dividing the numbers, and finally we are combining them. This is called conquering portion of left hand side. Come to the right hand side. 7, 3 and 4. So we are dividing the number into 7, 3 and 4. 7, 3 is swapped. 7 and it is divided into two parts, 7 and 3. 7, 3 is smaller than 7, so 3 is placed here and 7 is placed here, and 4 is a single entity, so no changes there. Now the first element of the first array is compared with the first element of one array. So 3 is compared with 4, 3 is already smaller, no changes there. Second element of the first array is compared with the first element of the array, that is 4. Yes, 4 is smaller than 7, so 4 is placed here and 7 is placed here. So the new sorted array becomes 3, 4 and 7. Right? So there are two different array, 5, 6, 8, 10 and 3, 4, 7. Now you will think that, sir, now we will combine both of them. No, if I combine both of them, again the same process, they are in an unsorted manner. So we'll again have to compare. Again start with the basics. First element of the first array compared with the first element of the second array. 3 is smaller, 3 is placed here, 5 is placed here. Now second element of the first array is compared with the first element of the first array. Again 5 is compared with the element, no changes there. By this way it will move on, and finally we will get a sorted array. This is the idea of merge sort. Okay, divide and conquer rule. There is a small example, or there is a small program of how merge sort occurs. This is not actually the uh, recursive process. This is just a program for how merge sort occurs. You can run this program. Now there are some complexity. I have told you what is time complexity. Time complexity means how much time will the program take to run or execute. There are three complexity. First one is the worst case, second one is the best case, and third one is the average case. The best case means they are the elements that are present inside the array are already in a sorted manner. So the time complexity is big O of n log n. Just remind these terms. You don't have to go through it right now. Second one is the average case, when the elements are placed in such a way that some of the elements are in a puzzled manner and some of them are already sorted, right? Then it is called average time complexity. And the last one is the worst case time complexity. Money means they are not even from an ascending or descending order. That means they are not sorted properly, or not even a single elements are sorted. Then it is called worst case complexity. Now for merge sort, the best case, worst case, and the average case time complexity is big O of n log n. Remind this only. And another thing is space complexity. Space complexity means how what is the total space that can occur by any one of them. Now next one is quicksort algorithm. Again, it holds the same idea of divide and conquer rule, but in this thing there are three main parts. In the merge sort, you have taken only divide and conquer. Finally, in this step, the quicksort element, there are three main parts. One is the elements less than the pivot element. There is a pivot element and elements greater than the pivot element or the pivot element. So one is the pivot element, second one is the elements less than the pivot element, and thirdly is the elements greater than the pivot element. Okay, suppose in this set of numbers 6, 8, 17, 14, 25, 63, 37, 52, suppose 25 is the pivot element. That means on the left hand side we can see that on the left hand side of the pivot element all of them are less than 25, whereas on the right hand side all of them are greater than 25. So we can say that yes, 25 is a pivot element, right? So by this way it will move on. How it occurs? Take an example. We start with the number that is not the actual number. We start with the number 25, 52, 37, 63, 14, 17, 8, 6. These are the element set or the data set that is present. Now we make an element, the first element we prepare it as a pivot element. The first element of the array is called a pivot element for quicksort. Now we'll keep on traversing the list. If ai less than the pivot and ai not equal to pivot, we are making a pivot box where the elements will be placed. Okay, and we are starting the array with ai index and ending with j index. Okay, here also we'll keep on traversing the list from back if aj greater than pivot and aj not equal to pivot. If both sides we find the elements not satisfying their respective condition, we swap them. Yeah, obviously greater than and less than we have to check individual. So how will I go for it? Okay, so I'll start with 25. 25 is checked with 52. Yes, it is smaller, no problem. 25 greater than 37. Yes, it is no change. 25 greater than 63. No change. Is 14. 14 is checked. 25 is here. Again with the same process I'll move on. That means ai less than the pivot. I will have to place the elements, smaller elements on the left hand side and the larger elements, my idea was there, larger elements on the right hand side. It might not mean a sorted process, but we will place the elements. Now here in this example I have told you that 25 is in the middle, it is the pivot element. I have taken 25 as the pivot element. So here 25 is the pivot. You can see all of the left hand side elements are less than 25 and right hand side elements are greater than 25, but you can see that both the left and the right hand side are in an unsorted manner. So again we will take 6, 8, 17, 14 as one array and 63, 37 and 52 as another array. We will swap in the same process, or we will sort in the same process how the actual or this element set was done. So again we will start with another element. 6 is the pivot element. By checking we will prepare such a number where we can say that Yes, this element is the pivot element. We can easily see that 14 is the next pivot element. If 14 is on the left hand side, 17 is on the right hand side, because on the left hand side of 14 all of them are smaller than 14, but on the right hand side of 14 17 is greater. So the new set becomes 6, 8, 14, 17. 25 is fixed, we cannot change it. Again come to this portion. If we take 52 as the pivot element by swapping, we first take the 63 as the pivot element, no changes there, so it will move on, the pivot portion will change. Say if we take 52, we'll see that 52 comes in the middle, so 37 is smaller than 52 on the left hand side and 63 is greater than 50 on the right hand side. Then we can say yes, they are in a sorted manner. This is the way how a quick sort occurs. Okay, here is the program for this quick sort algorithm. I have given an example of it. Again, it is not the recursive process. I have given two recursive programs in your site. You can view it. Here the time complexity is big O of n square, big O of n log n, and big O of n log n. Both average and best case are big O of n log n, but the worst case compulsory, because we have to check it in a again and again. First we are dividing it, then again we are calculating that portion or swapping those portion. For this reason it increases, so it becomes big O of n square. Okay, so if you have any query regarding this merge sort and the quick sort, you can ask me in the discussion forum of Moodle. It will be helpful for you also. I am applying to Flash player and a video which are uploaded with it also. You can go for it. It will be very much easy for you to learn, and the programs are also attached in the Word file. Take the help from it. They are in the recursive process.